In this video we will learn word operations which are N, OR, XOR, Invert, Decode, Encode, Select, Multiplex and Demultiplex. You may have studied these operations in a microcontroller if you have some subjects in your university. Let's see how we can use these operations. Let's review the simple N operation. In ladder language, we can have N logic, with series contacts. On the right side, we can see N logic operation, in FBD language. For this logic, we know the output is true if both the inputs are true. Here we can have N logic for 8, 16, or 32 bits at a same time. This is the ladder symbol of N. In this case, we must select the data type which can be byte, word, and double word. This instruction links the value at input in 1 to the value at input in 2 bit by bit, by N logic, and query the result at the output. Let's see what this instruction do. First input is F0. If we split this hexadecimal number into binary, we will have its equivalent binary number. This is the second input. As you see, if we want to enter a binary number, we use 2 plus sharp, and if we are writing a number base on hexadecimal form, we use 16 plus sharp. Alright, this instruction does N logic bit by bit. If we see, none of the two inputs are true at the same time, if we see bit by bit, and we know, the result of N logic of 0 and 1, is 0. So, when this instruction is activated, the result which here is 0 for all bits. Next instruction is OR logic. We know, in the OR logic, the output is 0, if only both inputs be 0. In other words, the output is true, if any of the inputs is true. Also we can have OR logic for byte, word, and double word addresses. This instruction links the value at input in 1, to the value at input in 2 bit by bit, by OR logic. Let's take the same example for this logic. In this case, the output is true, if any of the input is true. So, its result will be 1 for all output bits, so, we will see the FF hexadecimal number at the output. Next operation is XOR. This instruction links the value at input in 1, to the value at input in 2 bit by bit, by XOR logic. For this logic, the output will be true, if only one of two inputs be true. So, if we use this logic bit by bit, we can reach to its result. This binary number is equivalent to 3C on hexadecimal form. Let's test this logic in TIA. Here are word logic operations. Let me insert XOR logic. First, we must select its input-output data type. Then assign a byte memory address for each inputs and output. Now let's start simulation. Let's start PLC. Alright, we need to modify inputs to desired value. So right-click on each input and select Modify Operand. At this window, first determine format, and then enter desired value. With the same way, you can test other word logic operations. Next instruction, invert, is very simple. Like previous instructions, here, we must choose its input data type. This instruction invert the signal status of the bits, at its input. As you see, if we convert 1 to 0, and 0 to 1 for all bits, the invert of 0f hexadecimal number, will be F0. Let's see next instruction, decode. This instruction just accept a positive integer number, and its output data types can be byte, word, or double word. This instruction is used to set a bit in the output value, that is specified by the input value. For example, here, the output value is this number. If we activate this instruction, it sets the fourth bits of the output address, and reset other bits. Pay attention, bits number start from 0. So here, this bit will be 1 and other bits will be 0. The equivalent hexadecimal number of this result is 10, which will be sent to output. Next instruction is encode. This instruction reads the bit number of the least significant bit, in the input value, and send it to the output. For example, here, the bit number 3, is the first bit which is 1. So this instruction give us 3 at its output. Let's see next instruction, select. Here, I have chosen the short integer format for its output, which just needs a byte of memory. If we activate select instruction, depending on G input, this instruction selects one of the inputs, in 0 or in 1, and copies its content to the output. Here, in the left side, the G input value is false or 0, so the first input, number 10 will copy to output. If the G input value is true, then the second number, 20, will be copied to output. Next instruction is multiplex. If we activate this instruction, it copies the content of a selected input to output. Actually it's like select operation, but here, the desired input, is selected by a number at its k parameter. Here, its value is 0, so the first value at in0, which is 10, is copied to the output. If the k parameter is 1, the next input will be copy. For S7-1200, we can have up to 32 inputs and select one of them. Here, if the k parameter is not equal to 0, 1, or 2, the last input will be copied to output. Here, we see the last instruction at this video. Demultiplex. When we use this instruction, it copies the content of the input into a selected output. Here the k input is 0, so the number 25 will copy to first output. If it was 1, it is copied to next output. Otherwise this number is copied to last output. We can have up to 32 outputs, for S7-1200 CPUs. Let's do a simple project. Suppose there are 8 entering gates, which each gate has an optical sensor. Write a program, which each optical sensor can open its gate. Also, an operator can open and close all gates manually. Let define my input-output tags. First I need 2 push buttons to open and close gates. Then we have 8 sensors, which are connected to PLC inputs with byte number 1. Pay attention, we will use another input module besides CPU, for these sensors. I don't need to write all tags. Click here and drag it to insert other tags automatically. Also, we have 8 gate doors, which are connected to PLC outputs. Alright, first I need to modify my hardware configuration. Because I need 10 digital inputs, but my CPU support 8 inputs. So click on Device Configuration. Here, I'm using another digital input module besides CPU. Alright, you can see PLC output tags, but what about sensor tags? Pay attention, the address of this input module start from I8.0. But we have used byte 1, for sensors. So I must modify my PLC tags, or change the address of this module. Now, let's see how we can change default address of a module. Now, this input module and sensor addresses are matched together, and you can see defined tags for sensors on the module. Now let's start programming. You can use each sensor to open each gate. But here is a simpler way. I use a move instruction to open gate doors based on optical sensors. If the operator press open push button, I use OR logic, with this number to open all door. Also I can use AND logic to close all gates. Let's test this program with sim table. We have learned to use this table before. Alright, these are my defined tags. As you see, each sensor open its gate. If I press open push button, all gates will be open. And if I press close push button, all gates will be close. Thanks for watching. In the next video we will learn shift and rotate operations in TIA software.